Guys, and welcome back to this amazing channel. This is Abhinav, and in this particular video we'll discuss about all the 4 problems of biweekly contest 167. The contest was really good. I will say the first 2 problems were easy, not that easy. First one was very basic, very standard problem. Second one was little difficult, I will say. The third problem, design exam scorer, was not a difficult one, but based on some oops, there was some class and functions given to you on the basis of which you have to implement. But still, it was a good problem, a prefix sum based problem. And the last one is the maximum partition factor. So this problem was really good. It was a problem of bipartite graph. It does not seem to be a graph problem, but it was ultimately a graph problem, a bipartite graph problem. So yeah, we will discuss all the 4 problems of this particular contest. Uh, it took me one wrong solution in the first problem because of very silly mistake that I did, and then I finally solved it. Second problem I was able to solve in a good way, not so easy. Third problem I took some time because I was thinking that it is probably a problem of Fenwick tree or segment tree, but it ended up being problem of just simple prefix sum. And the fourth problem is actually of a bipartite graph. Here also I did one wrong summation because of something that I missed, a corner case I missed. Apart from that, this was also something which is good, right? So let's start with all the 4 problems one by one. Let me verify the recording. Yes. So guys, the first problem was very basic one. The problem says that key you are given with the I string, okay? And in this string, you have to check that whether there is any index I present such that the sum of positions of alphabet from 0 to I and I plus 1 to last is equal. So guys, this problem is very similar to the problem called find pivot index. I think that is present in pivot index problem in Leetcode, right? Yeah, this is the problem. So in this problem, the thing is that you need to find the index where for a given index its left sum means and right sum should be equal. You can say I did the same. The same thing is given in this problem also. The only difference is that here they wanted us to compare the sum of indexes of the alphabets, not just the number. Okay. So for example, I will give you the example. Okay. So let's say the case is, so I got a very good case. So let's say that the problem is like this. So let's say that your string is like this: A, B, D, C, D. In this string, if you will see, if you take this separate and this part separate, so sum of this part will be 1 plus 2 plus 4, because this is 1, this is 2, this is 4. And this second part will be 3 plus 4. So you can see both have sum 7. Means for this string, answer is possible, which is true. Now, how can we find? Okay. So guys, what I did is, I initially found the sum of the whole string. Okay. Why whole string? I will tell you. So let's say this is the indexing. And if you will find the sum of the whole string, it will come as 14. So it will be 1 plus 2 plus 4 plus 3 plus 4. Okay. So this will come out as 14. So I will say that total sum is 14. Up see guys, what logic will I use? So let's say guys that if you have a scale with you, okay, or a rod with you, and in that rod you know that the length of the rod is 10 meters, but this much part is 3 meter, and someone asks you the remaining part. So to find the remaining part, there is no need of again calculating it or measuring it. You can simply say the remaining part is 10 minus 3 means 7, right? And guys, the same logic, take a minute. Okay, and guys, the same logic I will use for this also. So here also what we will do is that we will take the total sum, which is 14 in our case. Okay, now what I will do is that I will start from first index and I will count something called left sum. Left sum means the sum of the elements or the characters present on the left of I. So you can say initially the left sum will be 0. So you can see in my code also, initially the left sum is 0 and I have calculated the total sum. Okay. Now what I will do, every time I will continue, what I will do is I will find the right sum. Ab dekho what is right sum? So let's say if we are here, left sum is the sum of elements before it. So if you are at I, there is nothing before it, so it's 0. But for right sum, right sum will be sum of elements from I till end. So right sum will be in this case. So basically right sum formula will be total minus left. So in this case it is 14. So it's not a problem. Okay. I will move forward and I will make left sum increase by 1 because this A was having index 1. Now I will come here. Now at this point left sum is 1, right sum will be 13. Then at this point left sum is 1, right sum is, it is increased by, so it became 3. And at this point you can see when you will add 4 more here, at this point left sum is 7 and right sum is also 7. Okay, so this was a simple prefix sum based code that I've written. I will tell you what mistake I did. So see guys, I solved this question before and the mistake was that here I need to take the index of that character, not the sky value. But I was taking directly a sky value, which actually worked for the given test case, the basic test cases, but did not work for the uh, one of the test case after running the solution. Okay, so this was a very basic problem. I hope that you understood this code. Okay, great. Now moving to the next problem. Next problem is longest Fibonacci subarray. This was also a very good problem. I solved it using DP. I just named this array as DP, but as we can't see this probably DP problem. If I will check the topics, it is okay. Topics are not celebrated, but it is not exactly DP. I will say, okay. Why not C? So if you will see this particular problem, it is saying that there is an array given to you, and in that array you have to find the longest sub array, which is also Fibonacci sub array. You know Fibonacci, right? Fibonacci means every number should be the sum of the previous two numbers. Okay, and obviously sub array of length 1 and 2 are always Fibonacci. So let's take an example. I will take some good example maybe. इसका आंसर 5 कैसे हो रहा है? अच्छा 5 है, ठीक है, मैं एक केस लेता हूँ. So let's say that the case is like this. एक मिनट रुकना यार, मैं थोड़ा सा ये ऑन कर लूँ, बहुत गर्मी है. आई वॉज इन बैंगलोर, वहाँ पे काफ़ी अच्छा वेदर है, बट यहाँ कानपुर में गर्मी है. सो आई प्लान कि मैं एसी ऑफ रखूँ, बट आई थिंक गर्मी बढ़ रही है. गिव मी अ मिनट. द प्रॉब्लम इज मतलब मैं फ़ैन को बहुत तेज़ नहीं रख सकता हूँ, अदरवाइज फ़ैन की आवाज़ आती है. अरे रिमोट. ठीक है, हाँ सॉरी. सो ठीक है, तो दिस इज एरे. ओके, नाउ लेट्स से द एरे इज लाइक दिस. 5 3 1 1 2 3 5 9 2 11. Okay, up in this array you can see there is always answer 2 is always possible, because you can take any subarray of size 2, and subarray of size 2 is always Fibonacci. You can see if you will take this one, yes it is Fibonacci. This one, yes Fibonacci, because for first two numbers of Fibonacci it can be anything. Next number of Fibonacci should be the sum of the previous two number. Many of you will say कि Abhinav, Fibonacci series always start from 1 and 1. This is not the case. Fibonacci series can actually start from any two numbers, and next number will be the sum of the previous two numbers. Simple. Up here, if you will see, there are multiple Fibonacci series also. You can see this is also Fibonacci series of size more than 2. Okay, by why? Because this is 9, this is 2, this is 11. And this is also Fibonacci. But the longest Fibonacci series is of size 5, which is this 1, 1, 2, 3, 5. Okay. Now, how can we find this thing? Now, देखो guys. So, a number is a part of Fibonacci if it is equal to the sum of previous two numbers. And if there is a Fibonacci series already present till the previous number, and if next number is also satisfying, it will also become the part of the same. So for example, if you will see, let's say I took these two numbers, which was 1 and 1. Now you can see this next number was sum of previous two. So I said, okay, this is a Fibonacci and this is of length 3. And you can see this also got 3. And this all 3 is also satisfying the sum of previous two. So means now it increased to 4 and 4. Now this one is satisfying sum of previous two, right? And till previous we were having a length of 4, so it became 5. Now thing is, how can we calculate it? So guys, for calculating the longest length, what I did is I initially took here answer 2. ठीक है, because answer 2 will always be possible, because length of this nums is also at least 3. It is in the constant, you can check. Now I took a DP array, and in DP array initially everything is 1. Why everything is 1? Because I am considering that every number is Fibonacci, because every number itself is always a Fibonacci series. So I made it 1. Okay. Now what I'm doing, guys, so initially it is 1, and initially we just need the first two numbers. So for the index 0 and 1 it will be 1. Now from index number 2 I am checking. Let's see what I'm checking. See guys, so I am first of all checking that whether this number is the sum of previous two or not. If it is not the sum of previous two, there is no update needed, because if it is not the sum of previous two means it cannot be the part of Fibonacci series. Okay. So if the number is not sum of previous two, I'm not even doing anything. I'm just keeping it as 1 as it is, because by default it is 1. This is also, you can see, is not equal to previous two, so it is 1. Now you can see guys, this 2 is actually equal to the previous 2. Okay. It is actually equal to previous 2. Now the thing is that अच्छा यहाँ पे मैं एक काम कर सकता था, I can put all the DPs to 2 also, because we know that कि every sub array of size 2 is 2, but ठीक है, मतलब I kept it 1, it's not a problem. Now this 2 is equal to the previous 2 number, means from previous 2 number taking this 2 we can have a Fibonacci series, right? So what I did is, whenever I'm finding that previous 2 number sum is equal to the current number, now I am updating the DP. And what I will do guys, I will just make DP of I equal to DP of I minus 1 1, and I will initially everything with 2. So what I'm doing is, or we can do one more thing, we can keep it nothing. We will make DP of 0 to 2, but I'm trying to make code little better so that you guys can easily understand it. That's the only thing. Otherwise DP of I equal to 2. Okay. This should also work, by the way. Let me first write and then I will tell you. ठीक है, 1 को मैं आप चाहो तो 1 कर देंगे, but does not matter actually. हाँ, solve हो गया, ठीक है. So yeah, what I'm saying is कि I initially kept 0 at 2 and 1 at 2. ठीक है, तो ये दोनों में 2 डाल दिए. And for all the cases where answer is not possible, I'm putting at 2. Why 2? Because we know that for every number, 2 sides Fibonacci is always present. Now guys, this number I got, and this number Fibonacci is, this number is equal to previous 2 number. That means it can be a part of a Fibonacci series. And we know that the previous Fibonacci series length was 2. And now we got this number. Now length of Fibonacci series at this index became 3 now. It became 3 now. Previous 2 plus 1, 3. Now you can see when I move forward, this one is also equal to previous 2, and previous one was 3, so this will become 4. So I am making DPI equal to DPI minus 1 plus 1. Now this one is also part, you can see. So this will become 5. Now this one is not equal to the sum of previous 2, right? So now it will again become 2. And then continue with, this will again become 2, and this will again become 3, because it is equal to the previous 2. So the maximum number that I got is 5, which is the answer. Okay. Okay. Amazing. Okay. So I hope that you got the understanding of this particular problem. Now let's move to the next problem, the third problem. This is a easy problem, yaar. Actually, I did it in first attempt only, but I took a lot of time to solve this problem. This was not a problem of that much time. I took a lot of time because I thought ki, see, first thing what I checked is that the numbers are up to 10 power 9. So I thought that it cannot be done in a direct way, because these much numbers we can't store in any array or any vector. There are a lot of numbers, 10 to the power 9 numbers are there. So I thought we cannot store it in a single array. It will give, it will create a problem. But later on I checked ki even if time is up to this value, but the total number of calls made will be 10 power, operations will be 10 power 5 only. That means we can use a vector. First thing, this I missed. And second thing I missed was that records will be in a strictly increasing time. Because of this, every time sorting and calculation is not required. This also I missed. Because of that, I was trying. So I missed this thing. So I thought it's a problem of segment tree or Fenwick tree, and because I didn't saw this is constant, then I saw it's a problem of Fenwick tree plus I thought it's a coordinate compression where I need to compress the coordinates to make it sorted, because 10^9 is very large. But actually it was not like that. It was a very straightforward question, very straightforward solution. So what you need to do is, guys, see, what you can do here is that you can simply maintain a prefix sum, okay, and in that prefix sum you can store the value. I will tell you how. So let's take that key. We have records like 1 comma 10, 3 comma 50, 7 comma 80. So what I will do, I will take here a times array which will actually store all the times, and take care of one thing, that times array is always increasing. Time will always get increasing. So time is 1, 3 and 7. Okay, 1, 3 and 7. Now I have a prefix sum array. Okay, I have a prefix sum array which will store the sum of scores up to a particular time. So you can see when initially a record will happen. So in every record, what I'm doing in the times array, I will just push back time. So like 1, I will push back 1, then 3, then 7. In prefix array, if prefix is empty, I'm just pushing back score. So let's say first time, I will just go with 10. Second time, when I'm inserting 50, what I will do is I will take the last prefix 10 plus 50, I'm making it 60 because it's a prefix sum array. And when I'm going with 80, it will be 80 plus 60, 150. So this prefix sum is giving me sum of score till that time. Means till time 3, score was 60, 10 plus 50. Till score 7, till time 7, score was 150. Till time 1, score was 10. Now this cannot be stored in this easy way always. Why not always? Let's say अगर यहाँ पर, so this is time and this is score. Let's say next entry जो आती है वो आती है हमारे पास 4,10. अब if next entry 4,10 comes, now if I am putting this 4 here, it will be a problem because it should be a sorted thing. Because if you are putting it 150, it is wrong. But the main thing was that it was a strictly increasing record. That is why it is possible. Okay, so I made it 140. I made it 140. इसके बाद it will be increased. Let's say now someone asked me, so you can see what I did, right? Record, you can check. So I am putting times, and in prefix, if prefix empty, obviously just a score. Otherwise, I'm adding the last one plus a score to maintain a cumulative sum. Okay, prefix sum. Okay. Now let's say someone asked me that I wanted a score from 2 to 7. So it is very easy. What I will do, I will first of all find the upper bound for R. Matlab, a index which is present just after 7. So you can see just after 7 there is no index. That means upper bound will come as 3 because there is nothing. Okay. Now what will happen? नहीं, upper bound उसका निकालेंगे. हाँ ठीक है. Upper bound, हाँ ठीक है. Now lower bound will come as lower bound of 2. So if you guys don't know lower bound, upper bound, please learn that what is lower bound, what is upper bound. It's very important. Okay, great. Now what I will do, if it is lower bound and upper bound, then it will come as 2 ka lower bound will be 3, because lower bound is index of a number which is greater than or equal to. Okay, it will come as 1. Okay, now what we will do कि but एक दिक्कत है इसमें, how it work, because upper bound when I'm explaining, I sometimes think कि I'm just sometimes thinking how to explain better, because it's always not possible. हाँ ठीक है, I think it should be fine. हाँ ठीक है, okay. हाँ, so I'm getting the upper bound. अब देखो, so upper bound is the index which is greater than the number. So to get exact that number, I can get. So here also, by the way, I can count the lower bound only, and in मतलब इसको हटा देते हैं. That will be fine actually. हाँ. So basically, I am finding the index where that time is present. ठीक है. So you can see that कि I wanted let's say a range. 2,7. मतलब records between 2 to 7. So what I will do, I will find the lower bound of 2. अब देखो 2 is not present in time, so I will get 3. This is lower bound. And for 7 lower boundaries will be 7. Upper bound will be 7 only. मतलब lower bound will be 7 only. So I got L here and R here. So this is the start, this is the end. मतलब from here to here. But what I will do, I know that till here the value is 140. Means I will get the prefix of R. But I want just till L. I do not want some before L. So I will subtract L minus 1 value from it. I'm subtracting L minus 1 from it. Matlab from 140 subtract 10, 130, which is the sum of record between that timestamp, sum of score. So it is a very standard problem of prefix sum and sub array sum, very standard problem. Okay, but just wanted to do it in a different way. I hope that you understood this. Okay, great, great, amazing. Okay, so this is one thing. And this time complex will be order of order of log n and order of 1. So record will be order of 1 because we are just inserting. This will be order of log n because we are finding the lower bound, which is actually binary sets. Okay, great, great. This should work actually. Lower bound. It should work. Oh, 1 minute. Why is it not working? हाँ, ये दिक्कत है, सॉरी. इक्वल तो हो सकता है इसलिए. It should be lower bound of start time, so I get the first index. अच्छा, oh, हाँ. So it's not a possibility that start is always present. ठीक है. So we will take actually upper bound here. I was just trying to make things easy, but नहीं हो पाएगा. So why I will take upper bound? Because it is a possibility that the last index which we want, that is not present in the times array. So I will take the next index and then before it. Okay. So that was the thing, but it is fine. Okay. So you will take lower bound. So why I'm saying that, let's say that range someone gave us. So I will tell you what's the reason. So let's say the range someone gave us is 2,5. Matlab I just want this 3 in the range. Okay. So for 2, lower bound will be 3. And for 5, upper bound will be 7. But I will not take this 7. I will take till before that. So I'm doing subtract 1. So basically, यहाँ भी r minus 1 होगा, एक तरीके से बोल सकते हैं. So that इसके पहले का ये लें सिर्फ, and this gets subtracted. Okay, great. Little bit logic here. I was just trying to make code better, just like I made. So obviously when I code during contest, that time I was just coding. I can't find how to write this in better way. That time I was just okay, let's complete the code. But when I explain, I see okay, there's a possibility of making code better. Like I did this one better, and this one I was trying to do better, but it is not possible actually. Okay. Now the last problem, guys, which is maximum partial factor. This is the last and obviously a hard problem. This problem does not looks like problem of graph. It maybe looks like because there is a 2D pointer, but we can't say it is a problem of bipartite graph. Or okay, you can say that also because there is a hint key. You need to split into two different groups. But let me first tell you what to do. Okay. So this is a problem of actually graph plus binary search, bipartite graph, binary search, and that. So the prerequisite for this problem, first of all, the first thing is that you should know the prerequisite of this problem, which is that how to check that whether a graph is bipartite or not. So if you guys don't know that how a graph is bipartite, please check out our editorial. अरे यार, उसमें वाई लगता है, सॉरी, बाइपर्टाइट में स्पेलिंग थोड़ा सा, या बाई नहीं लगता क्या? अरे आई लगता है यार, बाइपर्टाइट ना, आई लगता है, सॉरी गाइस, बर्पर्टाइट नहीं, बाइपर्टाइट, ठीक है. So in bipartite graph, what happens is, so let's first understand what is the bipartite graph. So a bipartite graph is a graph where we have nodes like this, 1, 2, 3, let's say like this, where there are actually टू ग्रुप्स ऑफ नोड्स, दो ग्रुप होते हैं नोड्स के, ठीक है, एंड दोज ग्रुप्स आर कनेक्टेड विथ ईच अदर थ्रू नोड्स like this, through edges obviously, not nodes, like this, but there is no connection of nodes present in the same group. So let's say this is group 1, this is group 2. So you can see no two nodes of this group are connected and no two nodes of this group are connected. इनमें से कोई भी नोड आपस में कनेक्टेड नहीं होती, इस ग्रुप की कोई भी नोड आपस में कनेक्टेड नहीं होती, ठीक है. ओनली नोड्स ऑफ वन एंड अनदर ग्रुप आर ज्वाइंट. तो एक ग्रुप में जो नोड्स हैं वो आपस में कनेक्टेड नहीं होंगी, दूसरे ग्रुप की आपस में कनेक्टेड नहीं होंगी, दोनों ग्रुप्स एक दूसरे से कनेक्टेड होंगे with the nodes. Got it? This is what a bipartite graph is, so that we can just divide it like this. I hope you got it. So if you guys wanted to learn more about bipartite graph, you can check. ये एक लीड कोड प्रॉब्लम भी है. There is a lead code का प्रॉब्लम specifically to check that if a graph is bipartite or not. ठीक है? And like in this way. ठीक है? And if you wanted to check that whether a graph is bipartite or not, so एक मेरे को इसमें हैकर रंग का मिला था. There was a hacker earth solution. हाँ ये रहा check. So you can check CP algorithm also. So to check whether a graph is bipartite or not, आपको क्या करना होता है? There is a one way using Q. This you can use, and there is one way using DFS. रुको. So this is the article. So if you will see here, this is an article where using DFS you can check that whether a graph is bipartite graph or not. So this is a DFS. There is a coloring in the graph that you have to do. Some coloring mechanism is there. But overall, this is the way how you can check that whether a graph is bipartite graph or not. Okay. So obviously I will not explain you about bipartite graph and its check in the video. I am expecting that you guys at least know that what a bipartite graph is, how to check whether a graph is bipartite or not, and its code. Okay. Ab how this problem is of bipartite graph, that I will explain you. Okay. So but I hope that you guys know what is bipartite. If you don't know, please go check some video and you can get about that what is bipartite graph. Okay. ठीक है. अब आते हैं वापस इस पे. अब let's see how this problem is of bipartite graph. ठीक है. अब देखो what they are saying. They are saying that कि there is a grid given to you where are some points. So it's kind of a 2D grid given to you. ठीक है. And in this 2D grid there are some points. I think all are positive points. I'm not sure. Achha, there can be negative points also. No worries. So some coordinates are there. Let's say this is one coordinate. This is one coordinate. This is one coordinate. This is one. This is one. This is one. And this is one. Okay. So there are some coordinates and obviously the indexes. Let's say this is x comma y. This is let's say x1 comma y. मतलब उसके आपको coordinates दे रखे हैं. ठीक है. And you know that what is Manhattan distance between two coordinates? Very basic thing. So the Manhattan distance between two coordinates is basically the absolute difference of their x and their y nodes. So basically the absolute difference होता है, that is called the distance between the two graphs. Okay, great. Now what you have to do? So you have to split those particular n points into two non-empty group. आपको क्या करना है? You have to split those points into two non-empty groups. ठीक है, मतलब let's say that there are 5 points given to us. So I will make 3 points in one graph and I will make 2 points in one graph. ठीक है, 2 points in one graph. ठीक है. Now what you will do? Now in each partition you have to find the minimum Manhattan distance that is present. So let's say in this partition there are 3 points, 1, 2, 3. अब let's say Manhattan distance between these 2 points is 3, these 2 points is 2, these 2 points is 1, let's say. ठीक है. So the minimum Manhattan distance that we are getting is 1. Here let's say there are 2 points only. So obviously when there are at least 2 points, then only it is possible. If there is just 1 point, then Manhattan distance will be 0 only. Let's say here Manhattan distance is 5. ठीक है. Here it is 5. Now if this is 5, then what I can do is कि here answer is 5. So I want to find the minimum Manhattan distance amongst all the possible pairs. So is partition mein I am getting minimum Manhattan 1, is partition I am getting minimum Manhattan 5, and maximum of both is 5, which is the answer. So this problem is little complex. Okay? So basically now summing up to a conclusion that you have some points, you have some n points given to you. Okay? You have to partition n points into two groups, let's say group 1 and group 2, such that their minimum Manhattan distance should be maximized. मतलब दोनों पॉइंट्स में जो मिनिमम मैनहट्टन डिस्टेंस है वो मैक्सिमाइज करना है. फॉर एग्जांपल तो उसके लिए हम कर क्या सकते हैं, सुनो. लेट्स से इफ वी नो दैट देयर आर सम पॉइंट्स which has Manhattan distance very less, मतलब those points are very closer, I will put all those points in one group. Let's say in this group I have some points which are very closer, and let's say their minimum Manhattan distance I'm getting is 2. Not an issue, but I will make one group where I will put only those points which are very far. Let's say one is here, one is here, one is here, and here let's say distances are minimum one out of them is 9. So answer will be 9. So if I do the partition in such a way that in first group I have all those points which are present, very nearer, having some very near point, and remaining all are present which are more. But how to find that value? मतलब how to say that on the basis of what value I will differentiate? किस value के basis पे difference करना चाहिए हमें? That we should know ना. So basically what I'm trying to say is that if I have, let's say, 10 points and I want to make two decisions, so what should be my base value? When I will say, let's say my base value is 5, so I will say all the nodes which are having distance less than 5 I will make at one place, all the nodes distance more than 5 I will place at one place. I can do that, but how do we determine that 5? For that I will put a binary cell. So what I'm doing is, guys, see here, I'm first of all, this is my main solution. Okay, first is the base case that if we have just two nodes then answer is 0, because if we have just 2 points then obviously in partition one will have 1 point, one will have 1 point, and 1 point each will not have any Manhattan distance. Answer is 0, because in partition we are getting 0 only. 1 point each, 1 point is 0. Otherwise what I will do, first of all I will find the Manhattan distance between every two nodes. So for every point I and j, I will find the Manhattan distance between that, and that I will store in a distance 2D vector called dist. So in this distance vector I'm storing Manhattan distance between any 2 points on the grid. So between every 2 points which are here, I will find the Manhattan distance. Okay, great. Now what I will do, to find what is the maximum distance possible, I will put a low and high check starting from 0 to high. I will find the mid, and for that mid I will check if for this mid it is possible, then I will try to increase the mid, and if it is not possible I will try to decrease the mid. You know, right, the basic binary says. Let's say initially it's 100, I'm checking for 50. Let's say for 50 it's not possible to divide into two groups. Ab how to divide I will tell, don't worry, I will take. But the main thing is that let's say we have min 0 max 100, or min 5 min 0 max 100, and I got mid as 50. Let's say that for 50 it is not possible. Now I will make from 0 to 50. Let's say for 25 also it is not possible. I will take 0 to 25. Basically not 50 but 49. Now here 24. Then here 23. Now let's say for 11 it is possible. Let's say for 11 it is possible. So if it is possible for 11, then I will say, bhai, ठीक है. Now I will try to increase. Now I will check from 11 to 23. 34. 70. ठीक है. This is basic binary search. But how to check that whether it is possible or not? This is the main thing. अब देखो guys, what I will do. So in the check possible function, I am passing the distance. Means, and sorry, distance is obviously there. The mid means I wanted to partition my coordinates into two groups such that one of the group has the minimum value mid. It cannot be less than mid. So what I will do, I will come to this check possible function. Now in check possible what I am doing. In check possible I am creating a graph and color. अब ग्राफ कौन सी वैल्यूज का बनेगा? सो सी गाइस, आई टोल्ड ना कि देर आर सम coordinates, okay, but I will make graph of only those coordinates which have distance, which has distance less than x. Because see guys, if we want our answer to be mid, then in at least one of the group all the distances should be more than or equal to group. It cannot be less than mid, because if it is less than mid, my answer will be mid, because हम मिनिमम ले रहे हैं ना हर ग्रुप का, हम दोनों ग्रुप का मिनिमम ले रहे हैं, उसका मैक्सिमम ले रहे हैं. तो अगर दो ग्रुप हैं तो एक ग्रुप में तो ऐसा होना ही चाहिए कि सारे डिस्टेंसेस जो पेयर्स हैं उनके मिड से बड़े या मिड हो. एक ग्रुप के छोटे हो सकते हैं. सो आई वांट वन ग्रुप जहां पे सारे बड़े. तो व्हाट आई एम डूइंग इज आई एम गेटिंग फर्स्ट दोज नोड्स whose distance is less than x. So let's say if between coordinate 0 and I and j, if distance is x, then I'm considering it in group 1. Let's say मतलब कि group 1 में we will be having only those points whose distance is less than x. So for example कि there was this point 1, point 2, point 3. ठीक है, अब distance here is एक और ले लेते हैं point, and let's say 0.5. okay, अब let's say distance is like this, there are this thing, okay, ऐसे करके ग्राफ है पूरा like this. So let's say that कि my mid is 10, मतलब I want distance at least 10. So in the graph I will take only those nodes which are less than 10, so that I can keep them in a separate group. So let's say मैं सब हटाता हूँ. Let's say that कि these are the connections, एक ये है और एक ये है, where the distance is 2 and 3 which was less than 10. तो ये तो चलेगा. And बाकी में let's say in these 2 points it was 100, मतलब more than 10. This was let's say 50, this was let's say 10 itself. तो कोई दिक्कत नहीं, मतलब amongst them all of them have more than 10. So sorry, मैं इसमें क्यों ज्वाइन कर रहा हूँ, that is a different group. मतलब let's say कि this is a different group because this is less than 10, but this is a different group because it is 100. ये तो कनेक्ट ही नहीं होगा because different group है. ठीक है, अब if this is a different group, there is one more problem. One more problem is that कि if this is different group it's fine because we got कि भाई चलो for this I and j distance was less than j, so I created it at a graph, but this should be a bipartite graph. This, so here this I am checking that graph should be. So if you check the bipartite graph, you can see this is the case that we do. We iterate, we check the DFS. So this is the check that I am making to check that whether my resultant graph is bipartite or not. अब why this graph which I'm making with the coordinates which are less than x should be bipartite? Because see guys, simple is that in these coordinates that we are making, the coordinates that we got, if they are able to divide into, so see, this graph will have coordinates which has less than 3, right? तो अब यहाँ भी क्या प्रॉब्लम है ना कि let's say that we want this edge which is less than 3 and this edge which is less than 3, but maybe this edge was more than, मतलब sorry, less than 10, but maybe this edge is less than 10 which is 20, and it is coming in this particular, getting right means it is making a problem. It can't, so it could be in the next one, right? So because I am storing only those edges where the distance is less than x, so if two what we can say parts are having distance less than x, 2 points I and j, so this is points, right? You can see I stored it for points. So if 2 points I and j have distance less than x, means they should be in a different part, this should be a different graph, and there should be no other which is greater than x. ठीक है, so let's say that from one point I got p1 p2, from one I got p1 p3, maybe P2, P3 can have this problem. P2, P3 are also in the same category. Now this will cause a problem. This should not happen. And how bipartite can restrict it? Because if there's a bipartite means, let's say P1, P2. Okay. So here I am putting only less than x, right? More than x is not there. That means this is P1, P2. तो यहाँ थोड़ा सा लॉजिक चेंज हुआ है. So I am saying this is P1, this is P2, and this is P3, P4, P5. So if I will get only those edges, let's say this edge, this edge, this edge, this edge. So if the graph that I form is coming like this, that means, and this graph has only those edges which are less than equal to my mid, sorry, less than mid. So you can see these graph, here we only have those edges which are less than mid. And if I remove these edges means if I keep these in a different graph, then remaining these, मतलब अगर मैं इसको divide कर दूं, so basically what I'm trying to say is कि now let's say this is a single graph, okay, this is a single graph, and this graph contains only those edges which are having distance less than mid. And if this single graph is bipartite, and if I divide these two nodes separate and these three separate, so what will it represent? It will represent that these three separate nodes and these two separate nodes will not have any edge or any difference less than mid, क्योंकि जो less than mid वाले थे वो उनमें थे आपस में, और हमने उनको अलग कर दिया तो वो नहीं बचे. इनमें जो बचे हैं वो मिड से बड़े या फिर इक्वल ही हैं. बात समझ में आई? I tried my best to explain. It was a hard problem. It took me some time to explain, but that is it. तो मैं क्या बोलना चाह रहा हूँ कि I will first of all find distance between every two node. I will check low and high, and for every mid I will check it is possible or not. How to check? So I will first create a graph of only those edges whose distance is less than x, means those edges which I don't need. So actually थोड़ा अलग हुआ. How we started? We started with making two groups where at one place nodes are very close, one place nodes are very far. That is what we are doing. We are doing a case where I am trying to divide on the basis that if we have those edges which are less than mid as a bipartite graph. So हमने सिर्फ वो edges लिया जो कि mid से कम थी. And if the resultant graph is bipartite, that means we can cut the graph from there, and remaining both the groups will not have edges less than mid, because जो less than mid थी वो graph हमने bipartite से काट दिया है. I hope you got it. So obviously for understanding this problem, you should have some good understanding of what is bipartite graph is and overall what is graph is. Okay, great, cool guys. So I hope that you understood this particular problem and the code and all the four problems. Contest was overall very good, I will say. I got some new learning, how I did some silly mistakes, as you can see. Okay, here also if you see bipartite graph, the silly mistake that I did, I didn't check for two nodes wala corner case. So yeah, cool guys. I hope that this video was helpful for you. If it is helpful, please comment helpful, subscribe to the channel. Thank you, take care, bye.